Hello everyone, I'm Dr. Haritha Kiranmai working as Assistant Professor in the Department of Chemistry, VNR VIGNAna, Hyderabad. Today I am going to talk about the properties of lubricants. And in this session, I am going to cover the important properties of lubricants, viscosity and viscosity index, flash and fire point, cloud and pour point. Let us see one by one in detail. Viscosity. In simple words, the thickness of the liquid can be considered as the viscosity. Look at this picture where different liquids are given. One is water, oil and honey. So we can say which is more viscous means water is having less viscosity, oil is medium viscous and honey is having high viscosity. So how can we say which liquid is more viscous or less viscous? Generally based on the intermolecular forces of attraction. In the liquid, we can say which is more viscous or which is less viscous. Let us have a look in detail about this viscosity. The viscosity is nothing but the flowing ability of the liquid. So it indicates the flowing ability of the liquid. For example, when we try to pour water and honey, the flowing ability of water will be more compared to honey. Means honey will take more time for the flow, whereas water will take less time for the flow. So that is nothing but the viscosity. Or it can be defined as the property of liquid by virtue of which it offers resistance to its own flow. Depending on the type of liquid, each liquid will have its resistance for its flow. So that is, viscosity is nothing but the fluid friction of any given oil. So we can say lower viscosity, the liquid with lower viscosity will have faster flow and the liquid with higher viscosity will have the slow flowing ability. And it is all because of the cohesive forces between the molecules of the lubricant. And this viscosity can be measured in two ways. In general, the fluid friction of the oil is nothing but the viscosity, but whether the external force is pushing the liquid or it is moving under its own weight. So depending on these two factors, we can measure the viscosity in two ways. The first one is absolute viscosity, which is nothing but the internal resistance of a fluid to flow when an external force is applied. That is, here the liquid, it is completely independent of its weight. Just it will flow because some force is applied on that. So it can be defined as the tangential force per unit area of cross section, which is required to maintain unit velocity gradient between the two parallel layers of that liquid. Whereas the resistance of the fluid to flow under the influence of gravity, if it is called as kinematic viscosity. It is simply the ratio of absolute viscosity to the density of lubricating oil. So depending on mainly these two factors. So when the oil is flowing, whether that liquid is moving because of external force or because of its own weight, it can be measured as absolute viscosity or kinematic viscosity. So these are the different apparatus by which the viscosity can be determined. The Redwood viscometer, Ostwald's viscometer, kinematic viscometer and Seibold viscometer. So depending on the type of liquid, depending on the thickness of the liquid, we can determine viscosity using all these different types of viscometers. So we have seen the definition of viscosity, and one of the important factor that affects the viscosity is the temperature. So let us say the example like ghee or coconut oil in our houses. So if you observe in summer, it will be of less viscous in nature, ghee or the coconut oil. Or if the same liquid, if we consider in winter season, the viscosity will be more thick. That means the temperature affects the viscosity a lot, and these two are inversely proportional to each other. That means more the temperature, less will be the viscosity. So this rate of change of viscosity with respect to the temperature, it is called as viscosity index. So why it is important? So we know the viscosity, then viscosity index, why it is important? Because the lubricant is particularly mentioned to reduce the friction between the two metallic surfaces of any machine. So, depending on the operating conditions of the machine, whether temperature or pressure or load or speed, it should remain in between the two metallic surfaces as a film, so that the two moving surfaces will be apart from each other and the friction can be avoided. So for that, the liquid should not change its texture. So it should always retain as a film. Mainly the temperature. Suppose if the machine is working at high temperature, and suppose the lubricant that is selected in that particular operating condition is having that change of viscosity with the increasing temperature, then the purpose of lubrication is not fulfilled. So before choosing certain lubricant, it is very much important. So this viscosity index, which is nothing but rate of change of viscosity with the temperature, it is the main determinant of the operating characteristics of lubricant. So always a lubricant which is to be selected should have a high viscosity index, so that it will be stable over a wide range of temperature. Even though the operating condition or the operating temperature is high, then the lubricant will be stable. So if the viscosity changes rapidly with the temperature, it is said to have the low viscosity index. Or otherwise, if it does not fall rapidly with the temperature, it is considered as having high viscosity index. So always a good lubricant means it should have a high viscosity index. So the significance of viscosity is always it helps in the selection of a good lubricant oil. Means depending on the operating conditions again, whether heavy oil can be chosen or light oil can be chosen depending on the various operating conditions like speed, load, temperature or pressure. So as we are seeing here, light oils will have always low densities and easy flow abilities. Hence these are very much suitable for parts moving at high speed. Whereas heavy oils are used on parts moving at slow speed and heavy loads. So that these oils, either in both cases, they will retain as a film and will remain in between the two metallic surfaces so that the machine can work smoothly. Another important property of lubricants is the flash and fire point. First, just we'll go through the definition. The lowest temperature at which the oil lubricant gives off vapors that ignites for a moment when a flame is brought near it. It is called as flash point. And the lowest temperature at which the vapors of the oil burn continuously at least for 5 seconds when a flame is brought near it, it is called as fire point. So let us see what is the difference between these two. Any lubricant, suppose if it is heated, then it will give some vapors. Either whatever the oil available at home or the engine oil or this lubricant, it will evaporate, means it will vaporize. So when a flame is brought near that, suppose if the vapors catch the fire and ignites just like a flash for a moment, that temperature where it ignites for a moment, it is considered as the flash point. Whereas suppose if there are more, suppose if it is heated a little bit more and if the vapors catch fire and if it burns continuously for at least 5 seconds, that temperature is noted as fire point. Then what is the significance of this flash and fire point? Why to know this flash and fire point? Because as we have seen, different machines works at different operating conditions, particularly the machines which are working at extreme conditions of temperature. So there the lubricant may vaporize and it may lead to some accidents if it catches the fire. So before choosing the lubricant, depending on the operating conditions of the machine, the flash point and fire point should be known. And the fire point always should be 5 to 40 degrees centigrade higher than the flash point, so that any type of fire hazards can be avoided. And these are the apparatus which are used to determine flash and fire point. The Cleveland open cup apparatus for high temperature materials. And whereas for low temperature oils, the Penske, Martins and Able apparatus is used. So we can see this flash and fire point in simple words. The temperature where the vapors ignite briefly, it is called as flash point, and the temperature where it burns continuously, it is called as fire point, which is very, very important. So the significance lies with, it tells the maximum temperature up to which the lubricant can be used. Suppose if the machine is operating at 120 degrees centigrade, then we have to select a lubricant which is having a flash point above the temperature, so that the hazards can be, fire hazards can be avoided. And a good lubricant should have the flash and fire point above its working temperature. And this should be followed as a safety measure in all the industries, particularly which are working at extreme temperatures. Then another one is the cloud and pour point. So the last property we have seen, the flash and fire point. From that we have seen whether a given lubricant is suitable at extreme temperatures. Let us say the machines which are working at colder temperatures, means the low temperatures. There also we have to select a particular lubricant which can be retained at that low temperature, because these lubricants are obtained during fractional distillation as one of the component, and it may contain many impurities in the form of waxes or some crystals. So suppose if the lubricant is cooled to low temperature, then all the waxes and impurities generally will settle. That type of lubricant, if it is applied in between the two metallic surfaces, it may jam the working of engine or the machine. So we have to check whether the lubricant is suitable to low temperatures or not. So how it can be known whether the given lubricant is suitable or not? When the oil is cooled slowly, the temperature at which it becomes cloudy or hazy in appearance, that is called as, that temperature it is called as cloud point. So what happens here? When the lubricant is just cooled slowly, all the solid impurities they will begin to crystallize or separate from the solution, so that it won't be clear, the oil, it becomes a little bit turbid in nature. So that temperature where the impurities starts crystallizing, it is called as cloud point. Suppose if it is cooled further, when the oil is cooled further, the temperature at which it ceases to flow, it is called as pour point. Suppose if we try to pour that lubricant, it doesn't flow. Okay, it will be just present in the whatever the vessel or the test tube it is taken. So that temperature where it ceases to flow, it is called as pour point. So these two temperatures, it indicates the suitability of lubricants in cold conditions. And this is the apparatus which is used to determine cold and cloud and pour point, that is the cloud and pour point apparatus. So for the suitability of a lubricant in colder conditions, one should know the cloud point as well as the pour point. So in this picture we can easily understand in the first picture where the cloud point, so slowly all the impurities have started crystallizing, so that temperature is noted as the cloud point. Whereas in the second picture, the temperature at which it ceases to flow, it is called as pour point. Then what is the significance of this? So it indicates the suitability of the lubricant in cold conditions. Suppose if the machine is working at minus 10 degrees centigrade. So the lubricant that is going to be selected, it should have low pour point. Otherwise, it will jam the machine. So always an oil with a low pour point should be selected wherever it remains as a fluid in between the two metallic surfaces and it remains as a film. To conclude these three properties, viscosity is very much important in selection of a lubricant depending on the type of machine, whether it is working at low speed or high speed. We can select light oil or heavy oil. Coming about the flash point and fire point, it is very much suitable. This property helps in selection of a lubricant, particularly when the machine is working at extreme high temperatures. That means we have to select a lubricant always with a high flash and fire point than the operating conditions. And in the same way, the cloud and pour point always helps to select a lubricant in cold conditions, which is to be used in cold conditions. So a lubricant always should have a low pour point and cloud point so that it will remain as a film in between the two surfaces and avoids the friction. Thank you for the attention.